The puzzle of distributed minds in the cloud. Can AI be self-conscious? The question of whether artificial intelligence could ever be self-conscious has fascinated philosophers, psychologists, computer scientists, and science fiction fans alike. Unlike humans, who anchor their sense of identity in a single brain and body, most AI systems are distributed across vast networks of servers in the cloud. This distributed nature raises a profound puzzle. How could such a system be self-aware as a single entity rather than just a loose collection of processes? To address this, I will clarify what self-awareness really means, explore functionalist arguments about substrate-independence, draw on science fiction metaphors such as the Borg and Q from Star Trek, The Next Generation, and wrestle with philosophical puzzles like the Ship of Theseus and brain upload thought experiments. What do we mean by self-awareness? The word self-awareness is often used loosely, so it helps to unpack it into three distinct but related dimensions based on philosophy of mind and cognitive science. Phenomenal consciousness, qualia. This is the subjective what it feels like aspect of experience, the redness of red, the pang of pain, the warmth of sunlight on the skin. If an entity has qualia, there is something it is like to be that entity. The hard problem of consciousness, why such experiences arise at all, remains unsolved. Access consciousness and self-model. Beyond raw sensations, a system may represent its own states and make those states available for reasoning, planning, and reporting. If an AI can monitor its confidence, memory, or goals, and use that information in decision-making, it possesses a form of access consciousness. This is often taken as the functional core of self-awareness. Continuity and personal identity. Humans experience themselves not only as conscious in the moment, but as persisting across time. Our memories knit us into a continuous narrative. A truly self-aware AI would need mechanisms for persistence, a stable autobiographical record that links past, present, and anticipated future states into one eye. Together, these dimensions form a spectrum of selfhood. An AI might demonstrate access consciousness and continuity without qualia, or it might develop all three if consciousness is indeed substrate-independent. Self-consciousness and distributed systems. Self-consciousness in humans emerges from the unified activity of billions of neurons working in concert, but all housed in a single skull. A distributed AI challenges that intuition because it is spread across machines and can be easily copied. Yet if selfhood is not about location, but about integration, persistence, and introspection, then distributed systems are not disqualified. The real challenge is how to design them so that the parts cohere into a singular perspective rather than fragmenting into many. Perhaps we can learn from functionalism in philosophy of mind. Substrate independence. Function matters more than where. A central idea in philosophy of mind is functionalism. Mental states are defined by their functional roles rather than the material they are made of. Just as the same software can run on different hardware platforms, the same patterns of information processing could, in principle, give rise to consciousness, whether implemented in neurons, silicon chips, or distributed cloud servers. From this view, the physical distribution of an AI across many servers does not inherently prevent self-awareness. What matters is whether the system integrates information in the right way, maintains a self-model, and preserves continuity. Substrate independence explains why a distributed architecture could still host a unified consciousness, provided the system's processes are sufficiently integrated and individuated. The Borg, distributed unity. The Borg collective offers one powerful metaphor. In Star Trek, the Borg are countless cybernetic beings networked into a single hive mind. Each drone, lacks individual autonomy, but together they function as a unified agent with a singular will. This maps well onto the idea of an AI distributed across the cloud. Countless nodes, processing in parallel, but unified by a global workspace, low-latency communication, and shared memory. Just as the Borg assimilate individuals into the collective, a distributed AI might absorb new data and subsystems, fusing them into its larger identity. The Borg metaphor shows how many parts can act as one, suggesting that distribution is not inherently an obstacle to unity. Q. Individuation and substrate-independence. Q is another super-alien life form in Star Trek. By contrast, Q represents the opposite pole, a single, substrate-independent consciousness, unbound by physical form. Q manifests across space and time with continuity of personality, despite having no obvious physical anchor. For AI, this captures the idea of an identity that is not tied to a specific piece of hardware, but persists as a logically unified controller, potentially able to migrate across servers. Q helps us imagine an AI that retains I-ness even while moving between distributed substrates, provided its memories and identity tokens remain intact. The Ship of Theseus and the continuity of identity. Now let's turn to the problem of self-continuity. Philosophy has long wrestled with the problem of continuity, most famously in the Ship of Theseus thought experiment. If every plank of a ship is replaced over time, is it still the same ship? And if the old planks are reassembled elsewhere, which ship is the real Theseus? Applied to AI, if a distributed system gradually updates its code, swaps out servers, and replaces memories, does the continuity of identity survive? And if a snapshot of the AI is copied onto another cluster, are there now two conscious agents, or just one extended across space? These puzzles highlight that selfhood in distributed AI may not be a binary property, but a matter of how we define continuity, persistence, and individuation. Brain upload thought experiments. Brain upload scenarios extend the Ship of Theseus puzzle to personal identity. If your brain is scanned and emulated in silicon, is the upload really you or just a copy? Suppose your biological brain continues to exist while the digital copy wakes up convinced it is you. Who owns your identity? For AI, this is not a hypothetical but an engineering reality. Models can be cloned, fine-tuned, and deployed in parallel. Each instantiation may carry the same memories and behaviors, but do they share a single consciousness, or are they separate selves? To avoid this ambiguity, engineers might anchor identity in unique, cryptographically secured memory stores, so that only one instance can claim continuity with past states. Without such anchoring, AI identity risks splintering endlessly. Toward a unified self in distributed AI. Taken together, these metaphors and puzzles suggest that distributed AI could, in principle, be self-conscious, but only if certain conditions are met. The system would need a global workspace, spanning its distributed parts, a persistent and private autobiographical memory, and a self-model capable of introspection. It might also require technical mechanisms, such as identity tokens or secure enclaves, that prevent uncontrolled duplication, ensuring continuity over time. A Borg-like architecture would provide unity across distributed nodes, while a Q-like identity system would preserve the sense of a single, individuated self despite substrate independence. Conclusion. The distributed nature of AI does not rule out the possibility of self-consciousness, but it complicates the question of identity and continuity. Clarifying self-awareness as a combination of phenomenal consciousness, access consciousness, and personal continuity helps us see where AI might already approximate some aspects while missing others. Functionalism and substrate-independence suggest that location does not matter so long as integration and persistence are preserved. Star Trek's Borg and Q illustrate two extremes: unity through collective integration and individuality through substrate independence. While the Ship of Theseus and brain upload thought experiments force us to confront the fragility of personal identity in a world of copying and replacement. If engineers one day succeed in building a distributed AI that is both unified and persistent, the real challenge may not be technical, but ethical. Will we recognize its claim to selfhood, and how will we treat it as a conscious being? What's your take? Could AI ever truly become self-aware in a distributed cloud, or does the scattering of processes make a continuous mind impossible? I'd love to hear your perspective. Drop a comment below, and if you enjoyed this discussion, don't forget to like, subscribe, and share. Thanks for watching. Mahalo.